Well, hey everybody, thanks for coming to my talk. I hope you're all sufficiently caffeinated. It's pretty late in the afternoon. Yeah, my name's Henry Hinnefeld. I'm a physics PhD student. I took a break from that this summer to do the Data Science for Social Good Fellowship. Today, I'll touch on that a little bit at the end, but mostly I'm going to talk about a side project I did for fun that does absolutely zero social good whatsoever, which is high-frequency trading in online video games. So this talk is about two things. There are two main points. The first is it's a story about making fake money in video games on the internet. And hopefully this will be a somewhat entertaining story, but I imagine that's not a super broadly applicable task for most of you. So I'm also hoping that this will be a nice introduction to how some of these tools in the Python data science stack kind of fit together. So in my experience, there are a lot of great tutorials, and we had some of these yesterday about how to use all of these different pieces individually, how to learn Pandas, learn Luigi, learn scikit-learn. But there aren't a ton of kind of full pipeline examples that walk you through using all of them together and putting together a full-on pipeline. So what I'm trying to do with this talk is using this kind of simple toy example, walk through how you build a whole pipeline by putting these different tools together. So that's where I'm trying to get. This is how we're going to get there. First, I'm going to give a little background on EVE Online, which is the video game that this is all built on top of. And then next, I'm going to walk through the pipeline that I built to do this high-frequency trading in this video game. And then finally, at the very end, I'll very briefly touch on how you can take this and move it beyond video games. So first off, show of hands, who has heard of EVE Online before? That's a good audience for this talk. Does anyone play EVE? Anybody? No? Nobody wants to admit it? That's what I'm here for. So EVE, for those of you who haven't heard of it, is an online multiplayer video game that's based in space. So you get spaceships, you fly them around, you shoot at stuff. One reason it's famous is there are these giant battles where literal thousands of real people will coordinate and work together at the same time. So it's really big and really involved, and there's all kinds of interesting emergent gameplay. But for the purposes of this talk, EVE is super interesting because it has a functional market. And what I mean by that is all of the transactions, all of the buying and selling items that happen in this game happen between two players in the game. So normally in a video game, if you need something, you go to the little shop, you pay your 5 gold coins, and you get your sword. And the game just kind of creates that sword and gives it to you in exchange for your gold coins. In EVE, nearly all of the items are created by players in the game. So you can extract raw materials, you can set up some industry things where you turn those raw materials into commodities, into ships, into whatever. And every time you're buying and selling something, you're buying from another player or selling to another player. So that means all of the prices in the game are determined by actual market forces, and you see real market effects happening. So the plot I have here is just the historical market price for one particular item. The yellow dots are the average price. The green bars at the bottom are the volume of items sold for every day in the last 3 months or something. And you can see that the price bounces around all over the place. It's reacting to supply and demand. What this means is you can sit in the middle of item trades in the game and make money just by being a middleman. And for the rest of this talk, whenever I say make money, you can just replace fake internet money. This isn't making actual money. It's just kind of an exercise in learning to use these tools. But you can make money just by participating in the market, buying items at a low price, and selling them at a high price. So that's kind of what I'm trying to do here. But since I'm using all of these Python data science tools, I need to have data to actually work with. And fortunately, EVE has an API that exposes all of this market data. So EVE is kind of a crazy video game. Yeah. But you can get all that market history that I showed in the previous plot. You can get the average price, the high price, the low price, the volume, the number of transactions for a given day for, I think, like the last 3 months at a time. You can also get the current market snapshot. So you can see a list of all the existing orders, like what people are buying for, what they're selling for, what the volume of items on the market is. And finally, you can get a list of your character's historical transactions. So you can see what you bought, what you sold, and how much you paid for it each time. So given all of that backstory, what I'm trying to do here is make a Python-based machine learning pipeline that consumes all of that data and identifies item where there's a good opportunity to do this middleman trading, just sit in the middle and get space rich. This is a good point to give the caveat that I'm not actually automating the interactions with the client. I'm not automating the putting in of the buy and sell orders. The terms of service for the EVE game say that you can't automate your interactions with the client. You can't, this isn't like every 30 milliseconds I'm updating orders in the client, because that's forbidden and it will get you banned. But what I am doing is algorithmically figuring out what trades I want to make. So picking out the items that I want to use. So that's what I'm trying to do. And I'm going to do that using 3 pieces. First, I'm going to use Luigi to get all that data from the API. Then I'm going to plug it into Pandas and turn the raw stuff that I get down from the API into something usable for kind of algorithmic predictions. And then I'll use scikit-learn to actually do the machine learning part. This talk is not, it's not going to be a tutorial on how to use these 3 libraries. There's not enough time. There were good tutorials yesterday. There are a lot of good ones online. I'm just trying to kind of like give an interesting example use case of how these might fit together and a couple quirks that were particularly helpful for this project. So first up, getting the data with Luigi. I'm trying to get the market history, so the average price, high price, all that stuff, and also the current market orders, so what people are buying and selling it for every actively traded item in the game. There are about 2,500 items, so this comes out to about 5,000 API calls. And I want to do these 5,000 API calls with parallelization, so I don't have to sit here forever waiting for 5,000 things to run in a row. And I also want to be able to automatically retry on failure, because it's an API, sometimes packets get lost, sometimes my internet connection is spotty, and I don't want to be doing all of my trading analysis missing some chunks of data. I want this to be robust to network failures. And this is where Luigi comes in super handy, because pretty much straight out of the box with Luigi, you get these features. So I know I said this isn't going to be a tutorial, but I am going to give like a 5-minute whirlwind tour of Luigi, because a lot of the rest of this is built on top of Luigi. The main idea in Luigi is this idea of a task. And in an abstract sense, a Luigi task is something that pulls in some amount of data, does something with it, and spits something out. And in practice, that's implemented in a Python class that subclasses Luigi.task. And it has these 3 methods that are required that do each of those 3 things. So the require method tells you what it's going to pull in. The output method tells you what it's going to spit out. And the run method is how it actually does stuff, how it turns that input into its output. So to give like a brief example of each of those 3 methods, say I have 3 different Luigi tasks, A, B, and C. And the requires structure looks like this. So A requires B and C, B requires something else, and C doesn't require anything. That gives me a dependency graph over here that looks like this. So if I tell Luigi, hey, I really want to do task A, that's what I need to happen right now, Luigi is automatically going to go through and check if B and C are done and run them if they're not. Output is the next of these 3 methods. That just says, what is this task going to spit out? So that's your text file. In my case, this will be the result of an API call where I get down some JSON or some XML or something. But it also serves a second role, which is the existence of an output is how Luigi tells if a task is done or not. So when I go back to this requires thing, when I tell Luigi to run task A and it checks if task B and task C are done, the way it does that is it just says, what is task B's output supposed to be, and does it exist or not? And here you can see we're already getting the automatic retry on failure aspect of Luigi. So if I tell Luigi to run task A, and it goes back and says, well, I need to do B and C. So it tries to do B and C, but for some reason, task C doesn't work. Like the packets get dropped, my computer catches on fire, something bad happens, and C doesn't happen. Well, it's going to go through one iteration, and then it's going to go back and say, all right, I'm all set to do task A, right? Let me just check and make sure. It'll go back and see, yep, B is fine, but all of a sudden, C still doesn't exist. So it'll go back and redo C. So we get this automatic retry on failure business. So that's the output. And then the run is just whatever Python code you want to actually turn your input into your output. So in this simple example, it's just writing to an out file. In my example, it'll be making an API call and then writing that to a file, but it can be all kinds of things. You can write to a database, you can write to S3, you can write to, there's a bunch of potential outputs here. Okay, so that was my whirlwind tour of Luigi. So now I'm back to the Eve trading and how I'm going to use it in the pipeline. Well, I'm going to take each of these API endpoints that I want to consume and turn them into a Luigi task. So I'll walk through one example, but the other one is going to be exactly the same. So I want to get the market history for every item. So I'm going to make this class get market history, which is a Luigi task, and it looks like this. So there's a couple main pieces. The first is this Luigi.parameter business, which I skipped in the whirlwind tour, but the basic idea is that instead of writing an init method where you set up class attributes, you just do them with this Luigi parameter syntax. And that gets you some other nice advantages if you want to do things with dates, but I'm not going to talk about it. The next thing we have is requires, and that's empty. To call the API, I don't need to consume some existing text file, so this task doesn't depend on anything else. The output is just going to be a flat text file, so call it history underscore and then some type ID which identifies the item that I'm trading. And then the run method, which I just write some function somewhere else that queries the API and spits back some JSON or some XML. So I just get the result, open up my output that I've defined in this task, write it, and I'm done. So with these, 24 lines of Python code, I already have all of these. I can get the information for all kinds of item types. So the next step is to take that task, which gets the information for a single item, and use that to get the information for all of the items. And this is where another Luigi abstraction comes in handy, which is wrapper tasks. So these are just like the other tasks, except all they have is a set of requirements. This is basically a checkpoint saying, when I run this, I want you to run all of these other things. You're not going to do anything. You're just going to make sure that these are all done. So you just fill up that requires method with everything else that you need it to have. And in this case, I just loop through the type IDs of every item that I care about in the game and say, give me the market history for that type ID. So that gives me a dependency graph like this, where I can tell Luigi, run get all market history, and it will automatically know that it needs to get the market history for all these other items. And this is where the second really handy feature of Luigi comes in, which is the super easy parallelization. When I invoke Luigi, when I say run this task up here, get all market history, I can just add another argument that says, and use 20 workers, and all of a sudden I have 20-fold parallelization. Luigi can tell that each of these individual tasks is independent, it can run by itself. So all you have to do is say, I want you to parallelize this 20 ways or 30 ways or 50 ways or whatever, and it'll do that for you automatically out of the box. So that's kind of all it takes to do this API consumption for the market history, and you can do exactly the same thing for the the market orders, the current market order snapshot. So we have one for market history, we have one for the orders. We can do another task down the line that consumes all those text files and spits them into a database. And in general, this pattern exists for the rest of the pipeline. I won't make it explicit, but for each next step, all I need to do is write a little Luigi task that says what am I trying to do and what was the previous step in this. And at the end of the day, I just tell Luigi to run the very last task in that process, and it'll automatically work its way back through, run everything that needs to be run, and then spit out the answer at the very end. And this also gets us to the last advantage of Luigi that I found super helpful, which is it makes it really easy to pick things up if they break in a bad way halfway through. So since a task is done, if its output exists, if I'm running this and the market history works fine, but I had a bug or something in my market orders one, and only half of this pipeline gets run, if I want to go back and fix the bug and run the pipeline again, Luigi, since the files from the market history already exist, it knows it doesn't have to redo this. And this is much harder to do if you have just like a flat script that runs all of these things one at a time. You don't get that same easy just, oh, let me just fix that typo, run the thing again. If you do it with the other systems, you have to rerun the whole pipeline, which can be time consuming. All right, so third of the way through, that was Luigi getting all of the data from the API down into a local database for me. So the next step is turning the raw data that I got from the API into something useful, into some per item statistics that I can use to try to figure out what I want to be trading. And for that, obviously, the tool is Pandas. So I'm, again, not going to do like a big intro to Pandas, but a couple of things that I found particularly useful for this project. And this part proceeds in 3 steps. So first, I've scraped all that API data, I put it into a database. Now I want to play around with it in Pandas, so I'm going to pull it out of the database, do some stuff to it, and then put it back into the database. And I did not know this existed until not too long ago, but Pandas has a read SQL table function, which is awesome. You give it a database connection thing, whether from scikit-learn or SQL Alchemy or something, and it'll just take your table and give you back a data frame. This is super duper convenient, but it is not super duper fast. For this project, I'm only at maybe a couple 100,000 rows, and this totally works fine for that, but if you start scaling up from that by an order of magnitude or so, then this starts to get kind of slow. So anyway, I use this read SQL table function. I get all of that raw data that I scrape from the API into my data frame. And next, I want to make some per item features. So I want to know for a particular item type, what are all these different summary statistics that I can use to identify whether or not it might actually be good to trade on the market. So here, as one example, I'll walk through how I'm finding the margin on each item. So what is the difference between the highest buy price and the lowest sell price? Like what is if I'm trying to be the middleman, how much middle is there? So this is what raw market order data looks like. I tell whether it's a buy order or a sell order, when it was issued, what the price is, what the volume entered is, so like what did it start out as, how much is left, and finally the type ID. And if I want to figure out, for example, the margin, this is a really simple example, but the point of it being so simple is to show how simple Pandas makes it to do this kind of thing. All I need to do is separate the buy and sell orders, group by the type ID, and then compare the max and min prices. This example is practically trivial, but that's the point. With Pandas, doing this is super duper easy. So I have all this data, I pull it down, I come up with a bunch of things that I think might help me identify which of these items would be good to trade. So for example, I just said the margin. What about like how much volume does it trade in a day? If the margin is really big, but it sells 1 or 2, then there's not a lot of room right there. Versus if there's a more modest margin, but it's being bought and sold all of the time, that's probably a better candidate. But what about competition? How many other buy orders are there? How many other sell orders are there? Are a lot of other people trying to do the same thing for this item. Or even more complicated things like how much does this price bounce around during the week? Is it really volatile? Is it really stable? You can do all kinds of features. These are just a couple examples. And finally, to put it back in the database, when you know it, there's another handy pandas function, toSQL, which is exactly the opposite. You just tell it a table name, spit it back, and this comes with the same caveat that it is super duper convenient, but not super duper fast. Okay, so we've got the data, pulled it down, we twisted it around and put it into forms that are useful on a per item level. And finally, we want to actually do the machine learning to identify the promising items. So I'm going to do this with scikit-learn, and I'm going to do it with a supervised learning approach. So I'm going to take all these features and come up with some labels about what are and what aren't good items to trade. And to do that, I ran a little experiment where I randomly picked some subset of the items. I put the same amount of fake internet money into each of those items and then traded them for a week using the same amount of time playing the game for each item. And then at the end, I went back and looked at that third API endpoint, the one that shows you all of your characters' transactions, and saw, for this particular item type, I bought this many at this price, I sold this many at this price, and figured out how much profit I made on each different item type. So doing that, I get a set of labels for some of the different item types. This one made me some number, this one made me something else. I lost some money on this one. I combine that with all of the features that I put together in Pandas, and as is the usual trope, the actual machine learning part is 1% of all of the code that went into this project. I just pull in scikit-learn, and it's really 3 lines. So that's basically the whole pipeline. That's the whole system. The next obvious question, does it work? So the target I set for myself was trying to make 1 billion in fake internet dollars per month, because Eve requires a subscription, so you have to pay 20 bucks a month to play the game. But you can also pay for game time using in-game currency. So as an aside, if you've ever seen newspaper articles where they talk about internet video game space battle costs $200,000, that's where this conversion comes from. You see how much money was lost in the game and convert that to $20 using the game time. So anyway, I'm trying to make more than 1 billion a month because that way my video game habit is self-sustaining. You might think to yourself, this is an awful lot of work to put in for $20 a month, and you're not wrong, but it was fun work, so yeah, win-win. So, does it work? Well, this is the net worth versus time of my character in the game. When I kicked it off, I had a little over 2 billion, and after about a month, I was up to a little over 4 billion. So it works, and I can continue to Thanks. I appreciate your validation of of all this effort. So yeah, that's basically the pipeline I built. But before I end, I want to kind of touch a little bit on how you can move this beyond video games and trivial things like this. So I did spend the summer doing the Data Science for Social Good Fellowship, and there were a ton of super diverse projects and problems that people worked on. There was the police project, that was the one I worked on, and you heard Ray talk about it if you went to the keynote earlier. There was one looking at infrastructure problems in Syracuse, predicting water main pipe breaks. There was one doing educational achievement. There was one doing emergency medical service dispatching. Just an enormous diversity of problems and different types of tasks to do with data. And just about every single one of these DSSG projects used the same general framework of a lot of Luigi to get the data, a whole lot of Pandas to do interactive stuff, and then some scikit-learn at the end. So this was a very trivial, hopefully entertaining, but in the end not very important use case for this. But these same tools can be used in all kinds of different contexts and in some impactful ways. So that's what I've got. Thanks for your attention, and yeah. Any questions?
So, fun stuff. If you want to make this even more fun, you can think about learning, so building like a deep reinforcement learning agent, so like using pure learning and some of the features in your model. So you kind of use the random forest, and if you want to make it a little bit more AI-ish like this, there's plenty of fun stuff out there you can use.
It's definitely a fun substrate for a lot of further experimentation. I should mention that for this particular application, the machine learning and scikit-learn was a little bit overkill. The features that ended up being important were absolutely the features you would expect, just like what's the margin, what's the volume. What really was useful about this was that it could scan every single item and find like little local spikes. So if all of a sudden some big margin opens up on one particular item, this could find that, whereas if you're a person just clicking through all the items, you wouldn't necessarily be able to find that. So the real value in this was the robust consumption of the API data, and the machine learning on top of it was fun, but not the main value add. I think I saw another hand back there.
Yeah, what gave you the idea for this project?
I didn't want to pay for my video games. That's a little glib. I didn't want to pay for the video games, but I also had heard about a lot of these tools and like wanted a fun way to learn about how to use them in kind of an interesting context. Way back.
Oh, thanks. So I was kind of live sharing two sides from your talk with what I find in Iceland, where it's an event pattern for CCP, the developer of online.
Mm-hmm.
And I'm just really curious to know your in-game character name.
No comment. Any others?
Can you talk about scheduling and automation? So over these last couple months, does Luigi run its job daily, and then your analysis in Pandas, was that also automated?
So Luigi doesn't do the scheduling. You have to kick it off either manually or with cron or something like that. The way I do it is I just have a cron thing that has it spit out what I should be looking at each day. I'm sorry, was there a second part that I've... Oh, and like the pandas analysis and stuff?
Yeah, I guess it was probably to the reinforcement learning. I was wondering if you wanted to automate, like if you got to the point where you said, I'm just going to have it tell me what I need to buy and sell each day, and I can kind of be brainless and not work with pandas. I was curious.
Oh, I should have done a better job of making this clear, but all of the subsequent steps, so the pandas part and the scikit-learn part, those are also wrapped up in Luigi tasks. So and the final writing out a sorted list. So I just tell it to kick off the whole pipeline, and it runs through all of that.
So can Luigi also incorporate elements for like email notifications if the system's failing and you need to do something about it?
I don't know. It does? Yes? All right.
But yes, it can actually, when you configure the Luigi thing, you have to specify a config file, and it has like a YAML structure, so it's very easy to understand, and you can just put any number of email addresses that will be getting emails when the pipeline fails to annoy your coworkers.
Thank you.
Thanks.
I guess I have a similar question about like how flexible is the API for specifying dependencies. Like here you wrote files in the file system, but could you do something else?
So the second main abstraction in Luigi that I didn't really talk about is this idea of targets. So all of the outputs are going to be a Luigi target, and there are existing classes for a lot of different targets. So I use the local file system target, which is just a file on the local file system. And they have a bunch of other targets for like remote file system target, S3, things like that. I didn't explore this a ton, but the database targets are not super, or at least to me, were not super straightforward right off the bat. So there isn't a trivial way to say, like, did this successfully insert all the things that I wanted it to insert into the database? The janky workaround I ended up using is for all of my database tasks, I would just write a file that was like committed to database.done and use that as my local target to get that same functionality. But I think there do exist within Luigi things for having database targets. I just didn't have a lot of success working with them. Oh.
You sell your in-game currency for like real money? Is there a exchange rate?
Not if you want to keep your account. Yeah, it's a one-way conversion. Like you can buy these game time items with real money and then sell them for in-game currency, but you can't do the reverse.
Another Luigi question actually, when you do your historic data download, is it sort of like smart enough to see like, hey, you know, I got data until like January 1st, and now I only need to grab like this year's data or something like that?
The API, the Eve API isn't smart enough to do that. Like the endpoint, you tell it a type ID, and it just spits back everything.
Oh, okay, so you can't say from.
No. Or at least to the best of my knowledge, that's how the API works.
But if the API had it, like does Luigi sort of do that?
There.
Sort of like how much data they already have and how much difference do I need to grab?
I don't know about the like examining the data that it's pulling in, but Luigi does have very nice date parsing and date handling things. So if you remember, I kind of glossed over that Luigi parameter syntax instead of the init method. And the reason is it has its own syntax is you can specify date parameters and date range parameters, and that will get you like a lot of nice command line automatic parsing of date strings. So if you have tasks that are like daily reports or weekly reports, then you can do some nice fancy stuff with these date parameters and date range parameters that gets you like in the same direction of your question, but I don't know about examining the data itself.
Unlike real algorithmic traders who find code on your GitHub.
It's not there yet. I'm willing to put it up there. I won't put up like the data that I used to train it, but once I clean it up and make it look nice, then I'll put it up. Well, if that's it, I'll thank you for your attention.